Hello, this is Matthew, and welcome back to part 2 of our video series on installing RAKF with a K on our MVS 3.8 mainframes. So after part 1, if we look at our dataset list here, we have successfully installed the base version of RAKF. So that was RAKF as it was originally released for the MVS 3.8 system. But since then, there have been 6 PTFs or patches or updates, and we don't yet have those installed. We don't yet have RAKF customized and activated and actually enforcing security. That's what we will do in part 3 of this video series. So in this part, we are going to install those 6 PTFs. This will give us a couple new features for RAKF, as well as fix a couple of bugs that folks have found along the way. So the good news is everything we need for the 6 PTFs is in our data set that we received from the CBT archive. So this file 850 data set, if we scroll down a little bit, here we are. So RRKF1, let me move that to the top of the list here. RRKF 001 through 006 are the 6 PTFs and all of the materials we need for those. So the files without the suffix, so just the numbers, these are the actual PTF definitions that we will receive with SMP, the System Modification Program. And some of them have extra elements. So essentially, data sets that need to be available when we are applying and accepting the PTF so that SMP can grab some additional members that aren't just defined inline in the text of the PTF definition itself. So all of these E files for PTFs 2, 4, 5, and 6, these are transmit files, so we will use the Receive 370 program to turn those into data sets on our system, and then we'll see how we reference those when we install the PTFs. And these I files, these are just informational. So if I actually look at that file, you can see that this is just additional documentation, and this is telling us how to use those elements files, how to receive them, and how to make them available to the PTF, or make them available to SMP when it's accepting and applying these PTFs. So the special instructions in the PTF itself, so if we look at the PTF itself, and this is just the input that goes into SMP, you can see that there are special instructions that talk about those elements archives. But this was originally distributed through the Yahoo groups and came as independent or individual zip files. And so you had to unzip those, get them into your system with Receive. So these extra info files are just those same instructions, but updated for the fact that rather than getting them from zip files, they're included here in the CBT file archive. So not a big deal. We know how to use Receive 370, so we can go ahead and receive these and put them somewhere where they will be available. The nice thing here is we can look in the instructions and it will tell us how much space we need for the particular elements data set. With one caveat that number 6 here, I think just used the same template as probably 2 and 5, and it doesn't actually have enough space. So we'll give it more space. We'll handle that when we get there. There's one other problem. RRK005 or RRKF005 in particular has been really problematic for me. There are a couple of problems. One is it uses, let's actually look, let's look at this PTF. So this is adding a utility called RAKend, and RAKend is a utility that we will use later in the process as part of the customization of our system to turn on RAKF and make sure security is enforced, that the documentation then also references later. So RAKend came as part of this PTF 5 to RAKF. And it's a utility, right? It'll be a program in our link lib that we can call from JCL jobs. The problem is it doesn't, it references a macro that does not exist right now in our system. And it's interesting because it includes one macro. Sorry, if we look somewhere here, yes, here we are. So part of what this PTF installs is this macro in the member IEZ CTGFL, and it's going to put that into RAKF's macro library, which is fine. But the code for this rack-end utility also refers to a macro called CTGPL. And I'm not sure what system this was built on where the PL macro would have been present, but the FL macro wasn't present. Because again, they're including in PTF5 this CTGFL macro. So we are going to need to get a copy of the IEZ CTGPL macro definition and add that to the system. And that will allow the rack-end utility to assemble cleanly, and we'll get a working copy of the rack-end utility. So that's good. That's fine. But the other problem is this this PTF, it doesn't, at least on my system and all the things I've tried, it doesn't actually successfully build that rack-end executable. You can see here that there's this JCL in portion of the PTF definition, and it looks like this is just meant to be inline JCL that runs and it assembles this rack-end utility. So rack-end will have been installed in rakf.sourcelib, and it then tries to link it and put it in sys1.linklib. And you can see here, this is an APF authorized utility. So it's putting it in a link lib that's in our APF authorized list. And that's all good. But this doesn't work for me. It doesn't actually build it. And I don't even really get any errors from the SMP jobs when it tries to run it. It just silently goes on and accepts and applies the PTF. Looking at the documentation for SMP, I do not think this is what the JCL in section is supposed to be used for. I mean, among other things, what if I used a different high-level qualifier for my RAKF stuff, right? We could have used whatever high-level qualifier we wanted, and through the DD names in the SMP jobs, the materials would have been directed to wherever we installed it. And the instructions even said, right, you can change this to whatever you want. So because this utility rack-end isn't being built through the normal SMP installation process, it's just being built by this sort of hard-coded inline JCL, that would be a problem. Now, we happen to be using the high-level qualifier RAKF, so this is fine. The other problem is, again, by just having this inline JCL that just assembles and links and puts an output in sys1 link lib, the rack-end utility isn't actually being managed by SMP. Even though it's a PTF that we're installing with SMP, because it's not really, it's not actually being built with SMP, SMP has no idea where this rack-end member of ultimately link lib will have come from. So you can't roll back, you can't write it. It's not actually being managed. And the other problem is I don't know how this is supposed to work, because we're telling the assembler here to output the assembled machine object code to this ampersand obj rackend, which is supposed to be this old existing data set. Although this notation, as far as I know in JCL, is always used for creating temporary data sets that are just used during the course of execution of this job, of this JCL. And so the fact that there's an old existing partitioned data set, because we're referring to a member name here, called OBJ, I don't understand what's happening here. There's probably a layer that I don't know, that I don't understand about the environment that SMP is going to run this JCL in, which may explain that, right? But if you just take this JCL and turn it into a job and just run it on your own, this won't work. It'll say this data set is not found. So I don't know how this is supposed to work, clearly, from what I've been saying here. But I'm saying all of this because we need to do two things. One, we need to make sure that that second macro that our system doesn't have is in the RAKF maclib. And we'll find a copy of that and do that. And that's easy enough. But then also, after we run all the PTFs, even though they will all successfully install, this rackend utility will not actually have successfully been built and put into sys1 linklib. So rather than going down the path of trying to figure out how to fix this, I figured it's easiest if after we install all the PTFs, the source for it will be in sourcelib, RAKF sourcelib rackend. So we have the assembler source. We can just assemble and link it ourselves and put it in, we'll go ahead and put it in sys2 linklib since it's not actually SMP managed. We'll build it ourselves and then we'll have the utility and everything will work fine. So that is a long, whoa, what did I just do? Don't know what I did there. I think I accidentally control clicked and that caused a problem. So where was I? Sorry, we're going to be building this on our own, and this JCL in the PTF, at least on the way this system is set up, doesn't work. Again, this was all built, I think, originally for the old original TK3 system. So maybe there was something in that environment where this would have worked, and if it had one of the macros and not the other for some reason, or who knows? But having beaten my head against the wall quite a bit on all of this, I figured out a system that mostly works, mostly keeps everything SMP managed. Like, we'll incorporate that extra macro definition into this PTF so that that's all actually managed in these data sets by SMP. But we're just going to have to manually install or manually assemble and link this rackend utility. So that's probably more than needed to be said on that topic, but that explains why later on we're going to be doing a couple things the way that we're doing them. Also, if anyone else is an SMP expert and can explain sort of how this was supposed to work, or if there would be a sort of more correct way to do it, right? I'm not sure why rackend isn't just being built or assembled and linked and installed by SMP directives in the PTF and not with that JCL in stuff. So I don't know. It's all a mystery to me. So if anyone has any hints or ideas of the history of that, let us know in the comments down below. So where were we? Right. So the first thing I'm going to do, just to get it out of the way, is let's go ahead and receive all of these elements members. So all of these transmit files. And we'll just stash them somewhere so that they're available for us to reference during installation. So again, not all 6 PTFs need them. Only 4 of them do. 2, 4, 5, and 6. So to do that, we will just write some receive 370 jobs, which we're pretty familiar with at this point. I'm going to do them, or I'm going to make that job in my RAKF install control library here, since that is where we have all the other JCL that we've installed or that we've used to install. So let's just edit. We'll call it receive elements. And this will be our receive 370 jobs. So MVS 01, we can call that R. This is going to be a job, give it an account number and programmer name. class A, and our message class will go to our held output queue. And we're going to need to do this 4 times. So PTF, let's call it PTF2 for short, is going to execute receive 370. And our transmit in, let's do disposition is shared, DSN. So this is where we have those elements input files. So this is in HMVS01.file 850. And the member name is the PTF name followed by an E. So the PTF name was RRKF002, and then E for the elements for 002. So where do we put it? Well, we need a new data set that we are going to catalog. And if this job fails, we're going to delete the data set. And I'm going to put them all under, we'll just put them up at RAKF. Let's call it rakf.ptf. And then I'll just use the same name, RKF002E. So that's going to be unit sysda. That'll land it on just one of our public, public volumes. Probably one of our work, the DASDs that have work in the name. The DCB, this can just match one of our existing data sets that we've restored. So I think I can just say, we can just even copy from RAKF install control. And then, of course, we need to give it space. So space, and if we look, let me start a new, start 3.4. If we look at the information, scroll down here. Yeah, so if we look at the information here, we can see the recommended space. It looks like we'll want track 621, and then we can release the extra space that doesn't get used. So let's just copy that and put it right as that. Did I start at the parenthesis? Yep, space is track 621. Release. So that should receive PTF2. From there, it'll make a new data set at RAKF002 elements, copy the data control block. So this is, record length 8, block size 5600. That all looks good. So I can use the block copy. So if you put 2 C's to say where you're copying from, and then you can say before to put it before this line. That will copy that whole block. And so PTF4 also had elements. So that's 4E. We'll put that in 4E. And I believe if we flip over and look at the info for 4, it is bigger. It's saying 30, 15, 1. So F9 back over to this guy, 30, 15, I'll hit insert so I don't overtype that, and then just one directory block. And then PTF 5, I'll say the notorious PTF 5 from everything I talked about, how we're going to have to do some extra work to make that work. So again, I'll just copy this PTF2 definition, put it before the end of the file there. PTF 5 is RKF005E, 5E. In this case, I think 621 was fine. We are going to be adding that extra macro member. Let's, again, just give ourselves a little more breathing room in the directory. And then PTF 6 is the last one. So again, I can copy, and we'll put that whole block before the end of the file. PTF 6, and that comes from RKF006E, RKF006E. This one, the information still just has this 621 allocation, but I think this is the new documentation, and it takes up much more space, so I think that was just a mistake in the documentation. Let's go ahead and use this 30, 15, and we're actually going to give it 5 directory blocks, because I think we also fail if we only keep one directory block. Okay, that's the end of that file. It just happens to perfectly fit on one screen. So let's just double check this really quick. We have our job card. We are running 4 steps named PTF 2, 4, 5, and 6, where we're receiving from RAKF 002E, 004E, 005E, 006E, and we are saving to rakf.ptf.rakf 002, 004E, 005E, 006E. All of the space looks reasonable. So let's submit this and see what happens. Okay, job submitted. I'll start 3.8. So there's our job. All right, all steps executed with a return code of 0, which means we were successful. So if you were to look through them, you'll see that, yeah, all of these different members from each of these steps has been restored. Okay, so that's great. Let's clean up a little bit here. I don't think we need this anymore. Well, for now. We'll come back to that later. And actually, let's close that out as well. Okay, so we're back to just one window here in review. So normally, and actually, let me switch over to the instructions here. We sort of skipped over the fact that where we were. So we did the CLPA. Okay, so here it's saying for PTF installation, we get those PTFs up to our system. They're already there because they came from the CBT archive. And then it's saying we can receive the jobs, and it is telling us that, let's see. Yeah, it's telling us that we will need to read any of the special instructions to have the additional materials available. So essentially all the instruction manual is telling us here is, again, we can just use our receive, apply, and accept jobs like before. But this time, instead of the base function for RAKF, we're going to be using the PTF's RAKF 001 and so on. It also mentions that as of the 6 PTFs that are here, there's nothing that stops us from receiving, applying, and accepting all of them together. That will save us a lot of time. So we are going to receive them all together, apply them all together, and then accept them all together. And here we go. This is where it mentions, yeah, make sure you check about these special instructions with those XMIs. So let's do that. Before we receive them, we want to update the PTF5 to have that extra macro that I mentioned. So the way we're going to do that is, since we received the transmit files, if we look in the RAKF PTF RAKF 005E data set here, here's where we have the source code for that RAKInd program that we talked about. RAKF remove is an example job for removing RAKF. And then here's that macro definition for the CTGFL macro. Yeah, here we go, CTGFL. But like I said, the RAKInd program also calls the CTGPL macro, which, like CTGFL, is not on our system. So how about a little archaeology here? So if you go to J. Mosley Hercules, and if we take a look at his site, I guess, so I'm trying to answer the question, where did these macros come from in the first place? And one of the places I found is that J. Mosley has archived a copy of everything from an MVS optional materials tape. So it appears that these macros would have come from an optional materials tape that you could have gotten from IBM and loaded onto your system. And he had an old copy of it, apparently burned to CD. And so he transferred them all into a 3380 volume You can download this as a DASD image. You can attach to your Hercules emulator and then mount this volume and attach a catalog in it to your system. And if you look at this cross-reference PDF, it has the contents of all of the data sets. So if we search for IEZCTGFL, which is our missing macro, you can see, sure enough, it's from, this would have been tape, I think, 6-1, or tape file 6-1 off of the optional materials tape. So that's great. That appears to be a authentic original source of this material from the MVS optional materials tape that would have gone along with our old MVS 3.8 system. So I did that, grabbed that macro, and I still got assembler errors trying to build that rack-end program. And so I dug around some more, and there is a different version of the IEZCTGFL member floating around out there that has, among other things, one extra variable defined, which the rack-end program ends up referring to. So basically, if you with this version of the macro from this MVS optional materials tape that Jay Mosley has posted, rack-end, you'll still get an assembler error of referencing a symbol that it doesn't know about. So other places, which if we look on Moshix's GitHub, and if we look in his repositories here, somewhere in here, he has uploaded a copy of the, here we go, sys1 maclib. So he says that these are the original unaltered macro libraries of IBM MVS 3.8J. And if you look down in the README, he says that this is the macro library, blah, blah, blah. It's different from the adapted, enhanced, fixed, and upgraded. Those are, yeah. So this is, again, this is supposed to be a original sort of restored from MVS 3.8J distributions of the system macro library. And sure enough, if we look on this page for IEZCTGPL, here we go. So we have the CTGPL macro that we need. And at the very bottom of this, this is actually one of the symbols that the rack-end code refers to that is in this copy of the macro, but is not in the copy off of the optional materials tape that Jay Mosley had. So I don't know where this version of the macro library came from. I don't know how these macros ended up in sys1 maclib. If they were from other data sets, from optional program materials. Nonetheless, I am very grateful that we can find a copy easily available online that has the version of the macro we need without having to go to like a TK4 system and just copy this macro out of it and into our system. It just saves us some time just being able to download this one file straight from the internet. So I'm going to copy this URL, which is just the macro text. And let's go back over to our Linux system here. And in my RAKF directory, I'm just going to grab that macro. So if we look at IEZCTGPL, okay, so that's all good. Okay, so let's use our file transfer support, and we are going to add that macro into the PTF5 elements data set alongside this other macro that it's installing for us. So let's get back out to our TSO prompt. We'll hit Control closing square bracket and say transfer. And this time we want to send a file we want to send RAKF IEZ CTG And on our MVS system, we want this to go into rakf.ptf.rrkf005e under the member name IEZ CTG It's a TSO system. This time it is an ASCII file, so we want it to translate it to EBCDIC when it uploads it to the mainframe. Remove carriage returns, remap the character set. We're going into an existing data set, so we don't need to provide any of the file attributes, and we'll send that up. Okay, transfer in progress. That'll be nice and quick. Transfer completed. So now if we go back in and we look at RRKF005E, there's our new member, IEZ CTG And if we look at that, it should look valid. And all the way down at the bottom, indeed, we have that CTG-REAS2 symbol that is apparently all important for the rack end utility. Okay, so that's one piece of the puzzle. The last piece of the puzzle, or, well, the second piece of the puzzle, the last piece will be when we manually assemble and link the rack end utility later. But as far as the SMP PTF definition goes, let's go into the definition HMVS01. Let's go into the definition for PTF5, which is right all the way down at the bottom of the screen here. Let's edit that. And somewhere in here, yeah, so here's the line that's telling SMP that this PTF is installing this IEZ CTGFL member from the rackend data set. We'll copy that line right below it, and we will tell it we are also installing CTGPL. So now this file in the RAKF maclib will get there and be managed by SMP. So that's just a nice, clean way to do it instead of manually copying it up into an SMP managed data set, which is the rakf.maclib. Okay. So all of that was to partially fix this RAKF5 PTF. All the other PTFs, 1, 2, 3, 4, and 6, they work perfectly. They are correct out of the box to run on our system here. So again, there were just some things about this PTF5 that I didn't quite understand, and I suspect are maybe making some assumptions about running on a system that is very different from the system that we have here. Okay, so with that, how do we actually install these PTFs? It's all pretty straightforward from here. We will edit our install jobs. So the first step to install SMP packages is to receive the sysmods into SMP itself. So that's the receive job. And instead of coming from tape, these are going to come from those members in our CBT archive. So these are existing data sets, and we have them at hmvs01.file850, and the member is rrkf001 for the first one. Let's get rid of this line that would load from tape. And then we're just going to make this SMP PTF in DD a concatenation of all of the PTFs. So hmvs01.file850 rrkf002. Again, there's going to be through 6, so I can copy this line, and then I can say insert it above this line. We have 4 left, 4 times B4. And that gives me 4 copies of that line. So I can just change that to 3, 4, 5, and 6. And then we'll tell SMP we want to receive. So receive is an SMP command. S is short for select. So we're selecting the PTF names we're interested in. And that's going to be RRKF001, RRKF002, RRKF003, 4, 5, and 6. And then the period to end the SMP command, the receive command. Okay, let's double check that. We are receiving from these 6 members of file 850 the following 6 PTFs. That looks correct. So let's submit that job. Take a look in our output browser. We need to do st star. And all the way down at the bottom, we should see RAKF receive. And it looks like that worked. We have a return code of 0. If we go to the bottom, receive summary report. Yep, 1, 2, 3, 4, 5, 6, status received. So that's perfect. Those worked. So the next step is to apply them. So if we go down, let's scroll the supply to the top of our screen. Same sort of setup as before. They're going to all of the same distribution and target libraries. Again, we're going to apply, and then we're going to select the 6 PTFs that we're installing. We're going to need an extra line here for the dis write. So I'm just going to copy that before I forget it. And then we select our RKF 001 through 6. So apply RKF 1, 2, 3, 4, 5, 6. That looks good. Now, this is where we need to make those additional elements available. So if you look at, let's look at the documentation again on the PTFs, the special installation instructions. So those are in MVS 01. If we look in the instructions for number 2, for example, it tells us that this data set, so for these elements that we restored with receive, we need to make them available to apply and accept through a DD name named elements. Okay, so PTF2 elements we make available as a DD name elements. Luckily for us, the other steps don't use the same name elements, so we're able to do them all at once because we can just make different names for the different PTF elements. So for example, if we look at 4, we need to make its elements available at the DD name doclib. And if we look at 5, we make its elements available at the DD name rackend. And then with 6, we make them available at the DD name, well, it's just the PDF name with elements, RRKF 006E. Okay, so remember all that. If you don't remember, I'll remember. So in our apply step here, we just need to add all of those DD names. So for PTF2, it was elements. This is going to be an existing data set at rakf.pdf.rrkf002e, because that's where we restored that transmit file to. And then again, I'm going to need basically 3 more of these lines. So I'm going to copy that, and I'm going to say B3 to add 3 more. And PTF4 said to make it available at the DD name doclib. So we'll do that. PTF5 said to make it available at the DD name rackend. So we'll do that. And then 6 simply wanted it at a DD name that matched the name of that element's member. So RAKF 006E, and we'll make the elements for 6 available. Okay, I'm concerned because blue here means the dataset doesn't exist. So let's browse really quick. Did I mistype the names when I restored them? rakf.ptf.rrkf 002E. What am I doing wrong here? RAKF, not PDF, PTF. There we go. Okay. That's a really nice feature of the review editor, by the way. Again, I don't think the actual ISPF editor from IBM does that. But when you refer to dataset names in the review editor here, you actually get a nice underline in the normal color if it exists, or it's blue if it can't find it. So saves us a job submission and then getting an error back and having to fix it and submit the job again. It's very convenient. Okay, is that everything? So that should be it. With that, we will be able to apply all 6 of these PTFs at once. The 4 PTFs that require elements that are not just in stream with the PTF definition, we're now pointing to here. And yeah, this should work. So let's just go ahead and submit this. I'm going to save it, submit, job submitted. Let's look at our output queue. Is that everything? And go to the bottom here. There it is, RAKF apply. Select that. We got a 4. This 4 is okay, like our original apply. That's just generated from an error and some link edit steps. So from SMP, a 4 is acceptable. If I go all the way to the bottom and scroll up to the individual... yep, so here we go. So sysmod RRKF1 is applied, 2 is applied, 3 is applied, 4 is applied, 5 is applied, and 6 is applied. So that's exactly what we wanted. That is a successful application of all 6 PTFs. And in fact, if we now exit out and look at, if we look at RAKF again, we can see if we look in RAKF maclib, for example, here are those 2 new macros we installed, right? So that's what SMP is doing. SMP is taking material from distribution media, which in this case were essentially the PTF definitions in the CBT tape file 850 PDS and those elements PDSs that we restored, and then it copies them into target libraries. And if they're like code that needs to be assembled and built, it will assemble them and it can put things into the link library, stuff like that. So we can see that that worked. We got those 2 new macros. In source lib, we now have the source for rack end. That wasn't there before. So that all worked. So I think I have 1 extra window that I want here. Yeah, so we'll just flip between the job output and this one editor. So again, at this point, you could do a CLPA IPL to apply, because again, this fixed some bugs and everything in that compiled member that's in the link pack area. Do some testing, all of that. We're just going to go ahead and accept all of these changes right away. So just like the last job, we have to update the accept job, and we will accept the PTFs that we just applied. So let me just update the commands here. RRKF 001, RRKF 002, 003, 004, 005, and 006. And the accept will also need to copy the material from those distribution libraries. So just like before, I need to add elements, doclib, rackend, and 006e as DD names here. So I will just type those in really quickly here. That was rakf.ptf.rrkf002e. And we can make, let's see, how many were there in total? We can make 3 copies of that. This is going to be 4, 5, and 6. And the names are doclib, rackend, and rrkf006e. Again, we know this because we read the special installation instructions that are near the top of each of the PTFs. So that should work. Let's go ahead and submit that. There's job 28. Looks like it didn't work. What did we do wrong? There's no-goes. Element DD card missing for, oh, I know what the problem is. When I prepared, oh, actually, no, I don't know what the problem is. Elements with an S on the end. Okay, try that again. There we go. That's a return code of 0. So now if we go to the bottom, we can see that if we scroll up a bit, yep, so again, so all 6, the status has now changed from applied to accepted. Okay, so the mistake I made there, I mistyped, or I forgot the S on the end of this DD name. It had to be elements, not element. Okay, so that's all 6 PTFs received, applied, and accepted. So they are installed. They're a permanent part of our system now. Now back to PTF 5. PTF 5 was supposed to install, if we remember that little JCL snippet, it was supposed to install into sys1 linklib a utility called rackend. But if I look in linklib and I go to the bottom, you can see that the RAKF installation did successfully install a couple of things. It installed RAKF profile and RAKF user, but there's no rackend to be seen. Because again, I don't see how that JCLN could have successfully done that. But no problem, because the source for that utility is here in RAKF source lib. It's right there, rackend. It's all just in that one file. We know we have the macros that are required to assemble it in here because we already looked. We have the both FL and PL because we incorporated that into the installation process. So we could write our JCL to assemble and link the rackend utility and spit it out into sys1.linklib, or to follow the conventions of our system here, we're going to put it in sys2.linklib. But there's another way to do that. Instead of writing out the JCL for the assembler and linker, we have not RFE, but RPF installed. So this is from Rob Prins. And again, it's a very sort of ISPF-like editor. I typically use review, but RPF has some nice features like the foreground assembler and link edit. So instead of having to know how to write all of that JCL, you just go into RPF, you choose option 4 for the foreground assembler, and we just fill out the form here to tell it what we want to assemble and where we want it to go. So our source library, so our source is that member rackend in the library rakf.sourcelib. Load lib, so this is where we're going to want the output to go. We're going to create a load module. We need to store it in a load lib. This is going to be called rackend insys2.linklib. What macro libraries do we want to make available to the assembler? Well, we want the standard system ones, and we also want rakf.maclib. That's how it's going to pull in the CTG, PL, and FL, among any other RAKF macros it uses. And we do want to assemble it. We do want to link edit it. And the only other thing is that this needs to be flagged as an APF authorized executable. So we're going to put AC equals 1 on the end of that. So if I hit enter here, there you go. That was successful. We got a 0 return code from the assembler. We got a 0 return code from the link editor. So we have successfully assembled and linked this rackend utility. So let's exit out of RPF, go back and do our familiar, at least to me, review front end. Now, if we look in sys2 linklib, if I browse this data set, sure enough, we got our rackend utility. So there are some jobs. We can preview them right here. If you look in the sample library, and if you look at, let's see, like vsam srack is one, where there's going to be a job step here that uses, here we go, that uses that rackend utility. So if we don't assemble and link and install that utility, some of the next steps in the manual for customization won't work. Okay, so with that little bit of sort of manual effort, the end result of how the system is supposed to be after PTF 5 is installed is now in fact the case. We have a working version of the rackend utility in an APF authorized library, which in our case, we're using sys2.linklib. The last thing we need to do here, I'm just going to log off, and we are going to need to re-IPL our system and rebuild the link pack area because, again, these PTFs changed the RAKF code, built new versions of RAKF for us. So because they're in the link pack area, we need to go ahead and do that CLPA IPL. So our usual routine here, we stop TSO. We znet quick to shut down VTAM. We stop all of the JES2 initiators. We stop JES2. We do the end of day processing. Oops, I should have waited probably for JES2 termination complete, but I'm impatient. And we say quiesce. Back over in Hercules, we're going to IPL 150 clear again. Back in our console, we reply 0 CLPA. Okay, so we're back up and running. RAKF is still installed. We haven't broken it with those PTFs. That's good. So now we will just continue our system startup like normal. So R0U, R1, we can just do a warm start of JES2. None of this affected any of the JES2 queues or spools or anything. And we will start net to get VTAM and TSO up and running again. All right, let's make sure we can still log into our system. Haven't broken anything. Log on MVS 1. Still not prompted for a password because we still haven't turned RAKF on. However, we are now in the great position, if we find the manual again, here we go, to begin what the manual calls customizing our system, customization. So this is where we're actually going to create our users and profile tables, and we will turn on RAKF. There's also some auxiliary utilities that we will install that are referenced by some of these jobs, but those are quick and easy. It's just one JCL job that's already written for us in the sample libraries. And then we'll go on to be able to use these sample jobs to initialize our bare bones user database and profile database. And let's see. Yeah, we'll create the password change database. So again, that's how RAKF lets users change their own password, is it just keeps a list of passwords that have been changed in a data set here that it reads. And we will also try going through, if we scroll down here, basically all of the existing data sets in the system do not have their data set protection flags set, which apparently can let people get around it. Any new data sets that are created after RAKF is installed and on will have the RAKF indicator turned on. But there are some utility scripts and batch jobs here that will just sweep through the system and turn the RAKF indicator on for all of the existing both VSAM and non-VSAM data sets. So we'll run those. It sounds like that's part of just making sure that really everything is protected, and it sort of finalizes the RAKF installation. So that has been part 2 of installing RAKF. We have now successfully installed RAKF from part 1. We have successfully applied all of the PTFs from here in part 2. Stay tuned for the next video in part 3, where we will finish up those customization steps, turn RAKF on, and actually start enforcing security on our system. So thanks so much for watching. As always, questions or comments, feel free to leave them below. And I will see you in part 3 tomorrow, if you're watching these videos as they come out, or perhaps as soon as in a few seconds, if you're watching these videos in the future and you decide to go on to the next one. Thanks again so much for watching, and I will talk to you later.